For a polynomial p of x, the value of p of 3 is negative 2. Which of the following must be true about p of x? I kind of hate this problem, but let's go ahead and do it. There's this thing called the remainder theorem, which actually proves this, but it's kind of hard to memorize. I think the easiest way to do this is just pick a function that makes this true. So it's like, for example, p of x equals x minus 5. So if you substitute p of 3 in there for x, instead of x minus 5, it's 3 minus 5. What's 3 minus 5? Negative 2. Let's try another one, like p of x equals x squared minus 11. So for p of 3, substitute 3 in for the x. So instead of x squared minus 11, it's 3 squared minus 11, and that equals negative 2. So then we can kind of go through this and just kind of eliminate. So x minus 5 is a factor of p of x. So we can look at any of these. Is x minus 5 a factor of x squared minus 11? So if we factor this, is x minus 5 a factor? No. Is x minus 2 a factor of x squared minus 11? No. So is x plus 2 a factor? No. So we get this, the remainder when p of x by x minus 3. And it actually works for both of these. So I'll just do the long division for this one. X minus 5 divided by x minus 3. So x can go into x once, and we have to put the 1 in the coefficient side. So 1. 1 times quantity x minus 3 is x minus 3. And then we subtract. X minus 5 minus x minus 3. So x minus x is 0. Negative 5 minus negative 3. Negative 5 minus negative 3 is the same thing as negative 5 plus positive 3, which is negative 2. So the remainder is negative 2. And you can also do this for x squared minus 11 divided by x minus 3. It's a little bit more complicated division, but the remainder will be negative 2. So by process of elimination, the answer is D.